Hey everybody, Ralph here. So I'm thinking about a project that uses segmented displays, but the ones you get from the store are either old-fashioned or way too complicated. See, most of them take one input per segment plus either a common ground or power. They also produce only one color. Now, they come in a lot of colors, but you still have to pick one, and I find that a bit boring. Adafruit does have this one, but just look at all those inputs. Nope, I want more. Or, well, less. We live in the 21st century, and I want a 21st century readout. I want any color at any time. I only want to deal with 4 pins maximum. I want to be able to chain as many together as needed, and I want to make them myself. Well, that last part's a lie. I'd much rather order them. Fortunately, the fine folks over at Adafruit have a possible solution if we want to put the little effort into putting things all together. I just love these little NeoPixels. I wish everything was as easy to use. As you can see, they come in a fair variety of sizes, shapes, and configurations. I have a variety on hand. For this project, I chose to try out these 3, but I had to change out the little fella, as my old eyes couldn't make out where pin 1 was. And although they aren't too expensive, after the 3rd attempt, I decided to cut my losses and start over. I ended up using the 2427 or 2.4 millimeter by 2.7 millimeter ones. They're bigger than I'd like, but way easier to use. I'll share the files for both, so be careful when picking which one to get made, so you end up with the right ones for the LEDs that you want to use. Now this project is pretty straightforward, but not without its unique issues. Besides changing out the tiny NeoPixel, I had to get some finer solder paste, as what I was using was having issues. Solder paste comes in fineness from 1 to 4. I usually use 2, but I got some 3 for this project and it works much better. Thanks again, Lady Idiot, as hearing you talk about the process in a recent show reminded me that sizes exist. The 3D printed shell is still not quite right, and the process for filling them with epoxy needs work. I ordered 20 millimeter syringes with real sharp tips and almost immediately stuck it into the tip of my finger, and 10 millimeter would have been better. They do make 10 millimeters with blunt tips, so you might want to look at those instead. I also would have used more pigment, as the mix I use is still too transparent. I have to say that the napkin made the best diffuser, with the transparent 3D printed one coming in second, so if anyone makes some of these and comes up with a better diffuser, please post it below. But all in all, they turned out passable. I designed the boards in dip trace and the shell in FreeCAD, then had the boards made at PCB Way. I used a modified Ender 3 V2 for the 3D printing, and a Miniware MHP30 for the reflow soldering. Hashtag not sponsored. I'm not recommending any of these, just sharing what I used in the project. I ordered a stencil with the boards, as I find that works better for me, but I've seen folks place smaller parts than these by just depositing some paste right out of the tube onto the board. The stencils don't cost a lot, but between them and the extra shipping, you could save some cash if you don't really need them. I found out just how short my attention span really is when placing the long NeoPixels. I didn't see any markings on the top, so I flipped them over to check out the pads on the bottom, but often forgot which way they were pointing by the time I flipped them back over right side up. Anyway, there are lots of ways to reflow solder and lots of resources on the internet to learn more about them. If you end up with one of these cute little things, be very careful, as even after you turn them off, the top stays extremely hot. Once I got the boards assembled and tested, I put them in the shells and ran some glue around where the board meets the shell and got most of them sealed. One had a small leak where some epoxy came through the bottom. I used white pigment, but was afraid to use too much, so ended up using way too little. After mixing it up, I poured it into the syringe and used that to deposit the epoxy into the shells. I tried to do a flood coat on the top, but I'd see if I could make a wall around the perimeter the next time to make it a little bit easier. Once they had cured, it was time to test them. as you can see in the code in the description below, they are super easy to use. There needs to be more error checking, but they work really well. One issue I ran into was counting by tenths, like 0.1 plus 0.1. I haven't done a lot of programming in the last 30 years, but I would have thought that someone would have figured out a way to do it right on a digital chip by now without making the poor programmer do so much hard work. See, when you're dealing with floating point math on a digital device, it won't always give the expected result. In this case, when it got far enough along, instead of getting, say, 0.8, it would give 0.799999 and cause an error. Since this was just a test, I didn't bother putting any check and correction code. So they work. They're super easy to wire up and use, and look okay for a first try. With any luck, by the time I get around to using them, a company will have started making them and selling a more improved version. We'll have to see about that. Anyway, thanks for watching. Make sure you hit that like and... Oh, dear God, I don't want to say that. Anyway, hope you had fun. See you next time.